More examples of simplifying radicals. We'll start here with example 4. For example 4, I've got 3 square root 108. With 3 square root 108, I have to determine how to break 108 down. So I come off to the side, I'm going to do my prime factorization. 108's even, so I know it divides by 2. Takes me to 54. 54 is even, so I divide by 2. Takes me to 27. 27 is divisible by 3, which takes me to 9. And then 9's a square, so I know that's 3 times 3. So I look at all these prime values, the prime factorization. I'm looking for pairs because the index has the implied 2. It's a square root. And so I could write this as 3. I've got a set of 2's, so I call that 2 squared. I've got a set of 3's and then another 3. I don't want to write this as 3 to the 3rd power because it doesn't match the index. The index will only allow squares to come out of the radical. So I'll write this as a 3 squared 3. That way I can allow this 3 to get out and that 3 will stay in. And so as I bring these values out, I have a 3, which I'm going to start calling these free values on the outside. Sometimes I'll refer to the inside as a jailed number. So I've got a free 3, a 2 that's coming out, that's free, a 3 that's coming out, and this one will stay in. So this would be a rad 3. So then I can multiply the free values. You're always allowed to multiply free with free and restricted or jailed with jailed. 3 times 2 is 6, and 6 times 3 is 18. So my final answer here would be 18 square root 3, or 18 rad 3. The word rad and square root are pretty much interchangeable for this lesson. Example 4, or example 5. Let's say we have something like -6 rad 150. So as we look at this, our square root value needs to be broken down. 150, I recognize that 5 can divide that. It goes in there 30 times. 5 goes into 36. And 6 can be broken down as 2 times 3. So when we look at that, we're trying to get a pair. We have that index of 2, the implied index of 2. So when I see these prime factorized numbers, I can call this -6 square root of a 5 squared, 2, and 3. This will allow the 5 to get out. So as the 5 comes out, I can take -6 times 5, which would be -30. And then with the radical, these two numbers are left in here. You've got to take this as far as it can go. So you have to multiply. You have to go back and reinvent the wheel. 2 times 3 would be 6. Don't leave me with any work. This is a simplified radical. You've multiplied the outside numbers. You've multiplied the inside numbers. That's an acceptable answer. Now I think we're ready to do an example 6 where I change the index. We won't see a whole lot of these in Algebra 1, but you do need to be aware of them. So maybe we'll have something like 2 cubed root. See, that has an index of 3. And maybe we'll go with 24. So when I do the prime factorization for 24, I need 3 of a kind to come through this gate, so to speak. And so I'll do my 24, divides by 2, takes me to 12, prime factoring, divide by 2 takes me to 6, divide by 2 takes me to 3. In this scenario, I see that I have the 3 2's. So as I rewrite this problem, it could be 2 cubed root of 2 cubed 3. The only way to get out of this airport security, this jail, whatever analogy you want to use, is you have to match that index. And so since this power matches that index, it tells me I could bring 1, 2 out, and it loses its power. It loses its index. That's like its ticket to get out. And so this comes out. 2 times 2 would be 4. And then you do have to write the cubed root of 3. Unlike our previous 5 examples, when I was doing a square root, it's implied that it's a 2. You don't need to write the 2 on any of these problems. Go back to my other paper here. You see, I didn't have any 2 as an index. It's implied that if you have a radical and there's no number there, that it's an index of 2. For this 6th example, when I say a cubed root, I have to have that 3 there all the way through, including in the answer, so that the reader knows that this was a 4 cubed root of 3. And so now we have 6 examples on how to simplify radicals.